Try again. Sorry about that. So my name is Edward Reiner. I'm a senior wetland scientist at the Environmental Protection Agency in Boston, Massachusetts. I've been there for 42 years protecting and helping to restore wetlands. And I'm going to talk to you about mitigating the environmental impacts from the I-95 abandoned highway embankment fill at Rumney Marsh, which is located in Revere and Saugus, Massachusetts.
And it looks great, Ed.
That's good. Similar to many of our East Coast marshes, almost half of the marsh has historically been filled. It's located just north of Boston, Massachusetts, about 5 miles. Between 1967 and 1969, 120 acres of marshland was filled to create an embankment 2.4 miles long with 6 million cubic yards of sands and gravels for a highway project that was abandoned in 1972. 444 acres are tidally restricted by this embankment, which only provided one opening for the water flow at a relocated Pines River. Why do we want to remove the embankment? Well, in general, it's to restore wetlands. And this is one of the greatest opportunities in the Commonwealth of Massachusetts to restore a wetland. After all, the highway was abandoned. It's not going to be built. And it's a stated goal in the 1988 designation of this marsh as part of the Rumney Marshes Area of Critical Environmental Concern, which is the state designation. Also, beneficial reuse of embankment soils for other public works projects can occur and has occurred, including beach nourishment for Revere and Winthrop shores. And it could be used for dune creation as part of other flood mitigation efforts. The I-95 embankment has been eroding for 50 or so years, and the impacts, believe it or not, are still continuing to this date. But the way we restore the habitat is to remove the fill. And by doing this, we've been able to restore intertidal habitat, which which developed into salt marsh over time, as you could see in these photos here. In the top right, this is a year maybe after construction. By 2011, it looks pretty darn good. Here's a 2014 photo. So just removing the fill and creating the proper elevations for the development of salt marsh has been very successful in restoring wetlands by embankment removal. This map shows the filled areas of Rumney Marsh, 45% in gray. In red are areas dominated by invasive species due to insufficient tidal flow, usually due to tide gates or undersized culverts. In yellow are areas where marsh restoration can still occur, and in green are completed marsh restoration projects. Here again is the path of I-95 embankment in purple, and you could see in this underlying image the creeks that were essentially cut off from flow and relocated into a straight channel to the relocated Pines River. I'm going to next show a series of aerial photographs to inform you about the development in the marshland. Here in 1938, you have a little bit of a community being developed in East Saugus. I think you might be able to see my pointer over here. And I'm going to just shift through some photographs quickly. By 1955, a landfill is being developed in Saugus. Here it's expanding with the development of dikes so that they could infill the salt marsh. This is prior to the Clean Water Act. By 1969, the landfill has extended across the full width of marshland between one road, Route 107, and the railroad. But you could also see that the I-95 embankment has now been constructed across the marsh just prior to the Clean Water Act. And the Pines River is being relocated in this photo. Here in 1971, just before the enactment of the Clean Water Act, the landfill has completely filled the path of water flow that would normally allow water from the Saugus River on the upper right over here to flow to the Pines River. Notice this area here where the beginning of a road is being constructed. And now there's a crescent-shaped marsh. This is a road to the landfill, and this is a waste incinerator facility that was constructed. So now we're in 1978 proceeding. Here's 1995, and removal actions have occurred over here in Revere for the Central Artery project in Boston to mitigate intertidal habitat impacts at Spectacle Island, as well as at Fort Point Channel filling under the Clean Water Act and state permits. By 2001, there's additional excavations that have occurred on the I-95 embankment. In the central location is a rectangular basin constructed to mitigate impacts of a Saugus River navigation project. There's a shoe-shaped excavation that occurred here to mitigate the impacts of a shoreline protection project at Rogan's Point and Revere. And here you can see all the central artery mitigation efforts are looking very good. Proceeding in 2005, 2008, 2010 over here, 2013. By 2014, there's additional excavation going on in Saugus for mining the I-95 embankment soils for Winthrop Shores excavation. And here is a mitigation area that was constructed to mitigate a project that improved a causeway to Nahant by the Department of Conservation and Recreation. By 2015, I'm just showing you that winters can be very cold in New England and a marsh can freeze fairly solid. Here's another photo in 2015 where a new excavation is being done to mitigate impacts at a Logan Airport runway safety improvement project in Boston. And here it's complete by 2017. All of the removal actions to date have had to maintain a flood protection berm built out of the original I-95 embankment soils based on the belief that the embankment was providing an accidental flood protection benefit to East Saugus. To date, out of the 120 acres of fill, well, we removed 37 acres, but we haven't addressed the issues associated with the restriction. So the purpose of an EPA study was to evaluate whether breaching the embankment to restore the formerly cut off drainage patterns would affect tidal flooding of low-lying residential and commercial property. We started our study with a bathymetric survey of the Pines River system. And I want you to just notice this bridge that we're next to represents an improvement to tidal hydrology that occurred that is also being evaluated by this study. Now, the bathymetry study found, which is depicted here in terms of the results, found deep scour holes at each of the three crossings, being the railroad, Route 107, and the I-95 embankment that never had a bridge constructed because this project was abandoned. Deep scour holes or scour is indicative of high velocity flows and typical of tidal restrictions. Here again, in yellow, is the path of the former channels. And you can see that the removal actions completed to date have essentially been designed so that we could ultimately breach the I-95 fill and restore these drainage patterns shown here. Now, there is also tidal restrictions in Saugus that I wanted to mention. I showed you pictures before of Crescent Marsh, which was developed with a road to the landfill. This culvert has collapsed. It was made out of corrugated metal. It rusted in a marine environment, even though it was asphalt coated. After 50 years, there was a cave-in, and this marsh is now drowned because the fresh water can't get out and the tidal water can't get in. But the DOT is currently replacing that pipe. At Ballard Street, there was a tie gate over here that broke off its hinge, believe it or not, 30 years ago. And it's been replaced ever since with a plate of steel to act as a makeshift tie gate while planning for a restoration project proceeded and unfortunately never occurred. The marsh also has a culvert at Bristow Street depicted here, which is providing flow from the east branch of the Pines River Bridge, which you saw a picture of. That bridge was improved in order to increase tidal flushing to the marsh. Now, the adverse impacts of tidal restrictions include decreased tidal flow and flushing, lowered wetland water levels, oxidation of marsh soils, which was discovered to cause some subsidence of coastal wetlands, believed to occur on the upstream side of I-95 here as well. Loss of detrital export to estuaries and bays, decreased salinity, a loss of shellfish, fish, and wildlife, a loss of native salt marsh vegetation with invasion of Phragmites or other invasive species, mosquito proliferation since the fish can't get to the creeks due to Phragmites, and loss of visibility across the marsh. Water quality degradation has also been studied at the Herring River in Wellfleet, Massachusetts by John Portnoy, who discovered that you can have acid sulfide soil development, sulfur mobilization, stream acidification, aluminum mobilization, summertime oxygen depletion, and fish kills. Thankfully, the Herring River is undergoing a restoration project to restore tidal flow. Observations of flooding, however, in this estuary reveal that it doesn't matter where you are, you get flooded. In East Saugus, on the upstream side of the embankment shown here, or here where a new house was developed in the floodplain, or in Lynn, shown here on the right, or in Saugus where water can overtop the Ballard Street. So we undertook a water level study by installing pressure transducers at 7 locations depicted here. We chose these locations to be on either side of each of the restrictions that we believed might be causing alterations to tidal flooding, including at Ballard Street to document the tidal leakage associated with the makeshift tie gate and the other culvert, as well as the Saugus River water levels. What we discovered is depicted here. We monitored this for 142 days, but we're only showing a 4-week interval here because all the results are essentially very similar to this. The top line in green represents the water level of the Saugus River, which was always higher than every other site. The water level on the bottom in blue represents Ballard Street salt marsh, which is tidally restricted by the makeshift tie gate and undersized culverts. The other 5 locations, however, only had a variation of between 2 to 3 centimeters, which the results are depicted here. We calculated the maximum water level observed during the study period, the mean higher high water level, which is the higher of the 2 daily tides we have in New England, as well as mean high water, which is the average of all high tides. And these results are also depicted here. As water flows underneath the railroad bridge, there's essentially no difference in water level elevations, which indicates that the railroad bridge at present sea level is not causing a tidal restriction. Whereas at Route 107, which had 3 bridges replaced, there's a slight diminishment of the height of the maximum tide by 2 to 3 tenths of a foot. Whereas at the I-95 embankment, there's a showing of a slight restriction. However, this restriction is diminishing as water levels increase because of the shape of the opening at the I-95 embankment crossing, which is shaped like a trapezoid. And therefore, as the tide increases, the trapezoid width is also increasing and the capacity for water flow is increasing. At Ballard Street salt marsh, there's as much as 2.5 feet of tidal restriction. Now, this graphic is interesting because we compared the 1989 Corps of Engineers studies with our study. And in 1989, shown here, the Corps of Engineers documented that there was a 0.3 of a foot difference at mean high water on the upstream side of I-95. Whereas in 2019, our study documented no difference. This is also showing that between the study dates, the difference at the Pines River site is 0.6 of a foot. This represents sea level increase over the last 30 or 40 years since the tidal datums used by the Corps in 1989 might have also been used by them in 1979. I'll say that it's a 40-year change. But at any rate, what we could also see is mean spring high water in 1989 had an 0.8 of a foot difference, whereas our mean higher high water difference is 0. The maximum tide levels was documented by the Corps of Engineers to be as much as 1.7 foot difference, whereas our maximum levels are only 0.2 of a foot difference. And as we mentioned, we believe this is due to the Route 107 Bridges Reconstruction Project. Depicted here, the bridge used to have a vertical sidewall on either side. However, it is now 3 times the length, and this has increased the capacity of water flow by more than 50% at 2 of the bridges. So this is depicted here in 2012 during the construction period. The tripled length opening of 2 of the bridges increased the capacity by more than 50%. And at the Pines River crossing, the permit plans showed a 28% increase in flow capacity due to the increased bridge length. Now, all of this means that our study has determined that the I-95 embankment is not causing a tidal restriction as previously documented by the Corps of Engineers in their 1989 study. That means that we can potentially breach the I-95 embankment to restore the drainage patterns shown here in blue. But rather than just restoring the creeks, we should restore the flow of water across the high marsh surface, sheet flow. That will help to decrease the erosion that's caused by the channelized flow from the channel that was constructed on the upstream side of the I-95 embankment. In conclusion, Route 107 bridges slightly restrict the tides in the Pines River estuary. Route 107 will continue to restrict the tides as well as storm surges due to its physical restriction to tidal flow. The abandoned I-95 embankment can be removed without increasing existing tidal flooding problems. The beneficial impacts of embankment removal include improved nursery and feeding habitat for 38 species of fish, hundreds of birds and other wildlife that frequent the marsh, improved sediment distribution for marsh accretion, improved coastal resiliency in the face of sea level rise, improved control of invasive species has already occurred because the I-95 embankment wasn't causing the restriction. Improved drainage for East Saugus is a critical element, and decreasing the erosion, of course, will help to restore salt marsh and intertidal habitat. So the suggested solutions going forward is to continue the removal of fill as mitigation of wetland impacts elsewhere, to potentially use in lieu fee program funding. That requires a competitive grant application. And unfortunately, the communities involved don't have the capacity to fill out grants. But continued beneficial use of fill is clearly a good thing because the Department of Conservation and Recreation could use the fill for other projects such as dune creation at Point of Pines or Revere Beach. And an additional source of funding could be supplemental environmental project funding for cases involving Clean Water Act violations, or grants for proactive wetland restoration. Lastly, one can consider if the community would like to enact a local bylaw to require mitigation for any floodplain fill. For more information, there's a couple of links here, and that concludes the presentation, and we'll open it up for questions.
Great, thank you, Ed. And just as a reminder to everyone, you can type your questions right into the chat section of the WebEx window. And either Ed will read those or I can read those out loud.
I'm trying to stop sharing. You could read it for me.
Yep. Jacob asks, is eroded sediment depositing on the marsh surface, and will the restoration of tidal hydrology, I assume, allow the marsh to keep pace with sea level rise?
I can't really answer that question. The reality is we don't have a lot of sediment coming into our marshes, and some of the sediment is really will be from the decay of the marsh itself, redistributing itself on top. Really, the marsh will grow. It's important to grow from its roots upward, and reestablishing proper growing conditions for the plants is critical. So what we're seeing now is waterlogging problems that need to be corrected. If we correct the waterlogging problems with runnel construction, for instance, that would help to allow plants to grow and hopefully keep pace with sea level rise.
Great. Any other questions out there that people want to ask? And since we do have a little bit of time, I'll also say that if anyone had any questions for Tom from the first presentation that you didn't get a chance to ask, you can submit those now as well.
I'd like to mention that a key interesting thing or change in Massachusetts is that the projects that occurred previously at Rumney Marsh to remove embankment fill were permittee responsible mitigation efforts. And the changes to the federal mitigation guidance favors mitigation banking and in lieu fee programs. We don't have mitigation banks in New England. That leaves in lieu fee program or occasional permittee responsible mitigation efforts to continue the efforts to restore Rumney Marsh, essentially.
And there is another question. Are there any distance restrictions on how far away the mitigation can occur?
Well, the way the in lieu fee program works is if somebody needs to pay into a mitigation fund for impacts, it would have to be in what's called the north coastal region of Boston, for instance. There's a south coastal region, there's a north coastal region, there's different regions that were set up through the in lieu fee program, which is administered by the Massachusetts Division of Fish and Game. And so as long as mitigation monies were from intertidal habitat impacts in that region, it could potentially be used at Rumney Marsh.
And just so you know, you've gotten several words of praise from attendees. Great presentation, beneficial study, very informative. Thank you for sharing all this great restoration work.
Well, you're welcome, everybody, but I have to convince the community that this is true, as well as the Department of Conservation and Recreation, who owns the land and has essentially an interest in a linear park creation. So you have some competing interests associated with, restoring the marsh versus maintaining a linear trail across the marsh. But I believe since the ACEC designation specifically called out the issue of the I-95 embankment, and the Secretary of Environmental Affairs wanted it all removed, that removal is a better action than maintaining a pathway for public access across the marsh. I'd much rather create a public access along the edge of the marsh if that was possible in the future, because the reality is sea level is rising. This community will flood. There's no hope for them unless they either relocate or build the formerly proposed floodgate project that the Corps of Engineers previously proposed in the 1980s. So it's quite dramatic. And the increased water flow caused by the Route 107 Bridges project is impacting the neighborhood in East Saugus. But the key to the issue is it's not because of the I-95 embankment that they're being flooded. And the removal, therefore, could help their situation rather than hurt them.
Great point. I don't see any other questions, but I do also want to remind everyone that you can, if you think of questions later, you can reach out to Ed or Tom on the Whova app, the virtual venue for the conference. All of the presenters and attendees are in there, and you can communicate with one another through the app. So I guess I want to thank Tom and Ed, and also Candace, actually, for helping with Tom's presentation. And I hope everybody has a great day.
Thank you.
Oh, and the session's being recorded, and it'll get posted eventually to the Whova site.